Good morning, Lexi. I apologize that I have not sent you not one proof. When I went on vacation, I didn't take everything with me by mistake, and so I didn't have stuff there to do it. Not to mention we were super busy, but anyway, I want to at least get some of these proofs to you. I looked at your records, and it looks like you are actually moving right along with your lessons. I am going to reset this problem, so if you want to go in there and correct it, you can do so. Okay, so this is coming from lesson 55. It's number 23. It is a proof where we want to prove that this shape right here is a parallelogram. That's what we're trying to prove here. Okay, so in order to do that, we would need to either prove that AB over here is parallel to EF, or BE is parallel to AF. Okay, that's what we would need to do in order for this to be a parallelogram, because remember, the definition of a parallelogram is that it has two pairs of parallel sides. But if we can prove just one of those parallel, then we can show that this is a parallelogram. So let's go ahead and get started on that. Get rid of all this stuff. And let me grab a different color here. We'll grab blue. Okay, so the first thing that we have here with this partially filled out formal proof is that triangle BCD, and I'm going to go ahead and highlight that. So BCD right here and EFD are congruent. EFD right here. Those two triangles are congruent. That is given information, so we can simply just fill in the word given for step number 1. Since those are two congruent triangles, that means that all corresponding parts would be congruent as well. So you'll notice that step 2 says that BC here, this line segment, is congruent to EF. Okay, why? Because of congruent parts of congruent triangles are congruent. That's the CPCTC. Remember, anytime you have two triangles that are congruent, then all of their corresponding parts will be congruent as well. You would have to pair up their matching sides or corresponding sides and also their corresponding angles. Okay. Number 3, we have another piece of given information by the looks of the reason for number 3. So we are going to write here that B is the midpoint of line segment AC in our triangle. Okay, so let's go look at that up here. So if B is the midpoint here, right there, I'm going to circle it. Whoops, I'm going to circle that. If B is the midpoint of AC, right here to here, then that means it has created two congruent line segments because it cut it right in the middle. It's landing right in the middle of AC. So now we have two sides that are congruent because of that midpoint. So let's write those down. So therefore, AB is congruent to BC. And why? The reason for that is already filled in because it's the definition of a midpoint. When a midpoint hits a line segment, it's created two equal line segments. Number 5. Now let's look at this. Okay, since we have, I'm going to try to highlight a few things for you here. Since we have, look at step number 2, BC is congruent to EF. And let's look down at step 4. BC is congruent to AB. So if BC is congruent to, grab a different color here, EF, if BC is congruent to EF and BC is congruent to AB, well then it stands to reason that AB, whoops, that's not what I wanted to do. I want to get a purple pen back. I'm going to write this in purple to match the circles there. Then that means that AB has to be congruent to EF. And we just do that. We're just substituting it in place of the two steps that we wrote in number 2 and 4. That is the transitive or substitution property. Number 6, okay, let's look here. We're told that angle C, let's go find that. Angle C, I'm going to mark that in purple up here. And angle DFE, DFE. Okay, they want to say something about those two. Okay, well, I want you to notice here, those are going to be corresponding angles. And since we have two triangles that I have marked in yellow up there that are congruent triangles, then all corresponding parts are congruent as well. So angle C is congruent to angle DFE because all corresponding parts of corresponding triangles are congruent. Now notice something here. If I were to extend out this line right here, put a little arrow here. If I extended those out, I want you to think about what that could be looking like. That is a transversal. So let's kind of bring this line out and this line out. And we'll pull this one out too because you'll be able to see it a little better for the way that we used to make parallel lines. So you'll notice that AC is a parallel line. Look over here. Let me highlight that for you in yellow. Here's A and here's C. So this line right here, actually let me do it in a different color. We'll do it in pink. This line and this line must be parallel because as that transversal cut through there, do this in green so you can see it. As that transversal cut through there, notice what it did. It created two equal, put little tick marks on there, angles. Okay, so since those two angles are congruent, which we identified in step number 6, then those must be parallel lines. AB must be parallel to EF. Why? Because notice that those angles at angle C and angle DFE are alternate interior angles. So alternate interior angles are created when cut by a transversal. When two lines are parallel, and I'm going to put the parallel symbol right there. And then finally, number 8, we'll write in our proof statement, A, B, E, F is a parallelogram. Okay, which states if one pair of opposite sides is both parallel and congruent, then a quadrilateral is a parallelogram. Okay, so that completes that proof right there. Alrighty, I hope that was helpful, and thanks for watching.